we're moving right along. We're in question 13. This is the problem that we did in class, okay? So I'm gonna ask you to go back and look at your notes in class on this one because we spent quite a long time on that one, okay? But no matter what, everyone should get part D right. Because part D is just plugging in 2.5 into the function, okay? All right, I'm gonna skip on to question number 14. Question number 14 is a rational expression, okay? So we want to simplify it, and the way we simplify it is we factor the numerator and factor the denominator, and we look for any common factors. All right, so if we needed to, we could use our method of, for the top one, of A times C would be negative 36, and they want to add to be 5. You could use your calculator if you needed to, but I can see that one, that's going to be 9 and 4, and it would have to be a negative 9 minus 4 would give me 5, and 9 times negative 4 would give me negative 36. So I'm going to say 9 and negative 4. So I factored the numerator. The bottom is a difference of squares. So I know that's the same thing as saying x squared minus 9 squared. So that's going to give me x plus 9 and x minus 9. That's difference of squares. Okay. So now, since I factored the numerator and denominator, this is how you're going to always simplify. It's your very last step for any fraction or rational expression. You look for common factors. You can see this factor and this factor. They're the same, so I can cancel them. So I'm left with x minus 4 over x minus 9. You are done here. This is the answer. Warning, warning. People want to simplify that x. They think they can cancel it. But you can only cancel factors, not terms. So if you're not sure, ask yourself, x minus 4 in the numerator, can you factor that? No. Put parentheses around it. And then the denominator, x minus 9, can you factor that? No. Put parentheses around it. And hopefully that'll help you from accidentally wanting to clean it up by canceling terms. You can only divide out factors. So this is your answer, okay? And when you're entering it, make sure that you can always see a preview. So come on over here. For example, if I type this in like this, which is wrong, you can hit preview and it will show you what the computer thinks you meant. Well, that's not what I meant, is it? So make sure you add in parentheses around your numerator and your denominator, okay? It's not about being neat, it's about being, that will be the only one that will be correct, okay? Number 15, this is also a rational expression. This time we're multiplying 2. Well, multiplication of fractions, we know that you just multiply the numerator times the numerator and the denominator times the denominator. So that's the same thing, saying 5 times p squared times, and I'm going to go ahead and factor the numerator, p plus 5 and p minus 5. That's p squared minus 25. That's what this is, this area in here. All right, so we factor those, and then the denominator, we could do the same thing. We could say a times c, will that be negative 40, and the middle term is negative 3. So we're looking for a factor pair that multiplies to negative 40 and adds to negative 3. If you need to, use your calculator as a crutch. So I'm going to try negative 8 and 5, because negative 8 plus 5 will be negative 3, and negative 8 times 5 will give me negative 40. And I put those both in as my second term. Remember, the reason I'm not dividing by a and simplifying is because it's 1, so it wouldn't make a difference. And then last, I have 25 and p. Okay? So now I want to simplify. I have everything factored. I want any kind of common factors that I can divide out. Well, I can see there's a p plus 5. Okay? And there's a 5. I can take that out of there. Okay? And there's a p, and I can take one of those out of there. So I'm left with p times p minus 5 over p minus 8. And you may leave it like that. You don't need to multiply it out. So I'm going to put it all here. I'm saying p times p minus 5 divided by p minus 8. Okay? And I can clearly see that's what I wanted. I hit submit. Oh, it said I got it wrong. What did I do wrong? Let's look at that again. Did I make a mistake? Yes, I did. I forgot this 5 here. There was a 5 here. I just overlooked him. So we would need to add him into our answer. So I'm going to type him like this. Here we go. And it says, let's try that. Much better. Okay. Number 16. Now, this is the one I warned you when we were doing this section that to me just seems a little strange. So just be careful. Don't let the formatting scare you. It says, look at this function. Okay. And it says, what is the domain? Well, we know that whatever the top is, we don't care. But the bottom cannot equal 0. Okay. We don't want it to equal 0. So what we're going to do is we're going to say what values for x make it equal to 0, and we're going to kick them out of our domain. So for the first part, it's going to always be x is not equal to m. That's what we're looking for. X is not equal to m for a rational expression. We're worried about the denominator not equaling, or equation, here we go. We want the denominator not to equal 0. So we're going to always choose this one. Okay? The other two are going to be used when we're talking about radicals, but for now, we're fine. Okay? The only time you'd pick all real numbers would be like, for example, if you had this function. Well, in this case, the denominator doesn't have an x in it, so x can be anything. So that would be all real numbers. But for what we're doing in practical case, we're going to always pick x is not equal to m, because that's what we're looking for, to see where are we going to make the denominator equal to 0, what values of x will cause that. Okay? So we want to stop that from happening, so we want to look at the denominator. We're going to set the denominator equal to 0, because that's what we want to stop happening. X squared minus 9 is equal to 0. What will cause that to equal 0? Well, we know that is a difference of squares, and we're going to set each factor equal to 0, and we're going to get -3 and 3. Now, people think that these are the domain, but actually the domain is all real numbers except for 3 and -3. But in our iMath AS, we're going to pick this one here because that's what they're saying. They're saying, what is your domain? Our domain is x cannot equal -3 and 3. And you just put a comma there, and then you hit submit. Oh, it says not all have been answered. That's okay. Oh, it didn't like that. Let's see why it didn't like that. Oh, I forgot to hit this first part. I'm sorry. Let's try that again. So don't feel like you have to put something in those last two boxes. They're going to stay empty. We're going to only use the one that matches this first x is not equal to m box in the rational function section of this class. Okay, because that's what we're trying to make the denominator always equal a number. We don't want it to ever equal 0.